Welcome to Differentiation for Student Readiness. In the next few minutes, we're going to look at readiness differentiation, what it means, and why research indicates that it is an essential educational practice. Let's get started. So what exactly do we mean by readiness differentiation? Well, there are three common types of differentiation. The first is differentiation for learning styles, such as verbal, visual, or musical. You also have differentiation for student interest, which accommodates student interests and passions as part of regular classroom dialogue. And differentiation for student readiness, which accommodates the skills, abilities, and background knowledge of students in order to set challenges at an appropriate level. Readiness differentiation in many ways requires the most planning and preparation of these three types. But given its essential role in building scaffolded learning opportunities for students, it's arguably also the most important. Because we know about Vygotsky's zone of proximal development, readiness differentiation just makes sense to most of us. Still, knowing what research says about the value of differentiation helps us to maximize our use of it. In short, research says that differentiation works because it connects learning to existing schema, encourages self-regulated learning, and helps us catch and correct student misconceptions as soon as possible. So when we say connects learning to existing schema, we're really talking about the value of readiness differentiation from a neurological perspective. We know how the brain works. Long-term memories cannot be made unless new knowledge fits into existing knowledge. In this diagram, existing knowledge is at the center of the student's experience. Students cannot retain new information without a logical fit in their brains, the circle that surrounds the existing schema. By crafting a learning experience in light of what students already know, a teacher ensures that learning is possible. It's up to the teacher to discern what and how much students already know, what misconceptions they may hold, and how to help them connect their existing knowledge to new concepts or skills. Activating students' initial understandings allows them to grasp, retain, and transfer new material. That's the star point on this diagram. Failing to activate those understandings will likely result in a failure to learn. This image shows one commonplace example of how teachers connect to existing schema all the time, by finding relevant connections from real life. Of course, if only a few of the students in this class knew or cared about football, this might not be a good warm-up problem for the entire math class. However, the teacher could divide the class into smaller groups by interest and assign a group of football enthusiasts this warm-up problem, which would definitely connect to their existing football schema. Self-regulated learning entails knowing what you know and what you need to learn. Self-regulated learners strategically set learning goals, plan steps to meet those goals, monitor progress, and know when and how to ask for help along the way. Self-regulated learners have a sense of intrinsic motivation and self-efficacy, and believe that errors afford learning opportunities. They are aware of their own strengths and limitations and attribute outcomes to factors over which they have control, such as planning, practice, and effort. While readiness differentiation doesn't teach self-regulated learning, it's impossible to create a class of self-regulated learners without differentiation. If the work is too challenging, students will be overly dependent on the teacher or one another. If work is too easy, students won't have a reason to self-regulate. This chart illustrates an easy-to-implement way of encouraging students to reflect on their performance, since you can use it after every test or quiz in any subject area or grade. Students need to see how to decide if a question is challenging or comfortable, and they need to learn to be aware of problem-solving strategies that are working for them. With the data from this chart in hand, you can really begin to cultivate a class where differentiation leads to self-regulated learning. Correcting students' misconceptions early is important because the longer a student holds on to a misconception, which is part of their schema, the more difficult it is to correct the misconception. Early detection and correction of student misconceptions is essential to their overall success. This example alerts the teacher to monitor a specific misconception, misplacing numbers in the numerator and denominator, and provides ways to correct the misconception right away by asking students to choose words to represent the numerators and denominators. In order to make the most of these helpful directions, a teacher would need to use number 1, the quick quiz, and number 2, the math journal, to effectively monitor which students might need to have this misconception corrected. Ultimately, we know that readiness differentiation works because it connects to existing schema, encourages self-regulated learning, and helps us catch and correct student misconceptions as soon as possible. In our next session, we'll be looking more closely at techniques that will help you to differentiate for readiness more effectively.